Hey guys, we're back with the notes for 5.1. We are starting systems. So if you would take a second, pause the screen, write down everything you see, and then we'll get started. Perfect. So first question I would like to ask you is, do you know what a system is? You've done systems in pretty much every single other course except math so far. So a system just means two or more things that are working together. It might be an ecosystem or a digestive system. It could be anything with more than one part that is working together. That's a system. So in algebra, a system of equations would mean two or more equations. Again, they could be inequalities, but they have to share something. They're working together to make a solution. So in those, they could share one solution. We'll show you what that looks like. They might share no solutions, or they might share infinite solutions. So before we start graphing, I do want to go to the back page and kind of write out so that you know what you're looking for. Okay, so let's go to the second page. I'm going to have you pause it for just a second and write down what you see. Perfect. So when we're talking about solutions, we have three different kinds of answers. I want you to know, very important, that your answers are these. Okay, this section over here is what the answer should look like. Okay, so what would you have to see in order to get that answer? Well, if you see intersecting lines, you're going to know that they share one solution. Your answer is going to be this point right here where they cross. If you see parallel lines, you're going to notice that they have no points in common. They have no solutions that they share. Finally, infinite solutions would mean that you see the exact same line stacked on top of itself. So you graph a line, and then you go to make the other one, and they are the exact same points. Okay? So they share one point, intersecting. They share no points, no solution, parallel. They share every single point, infinite solutions, if they're the same line. In as big of writing as you can fit on your paper, I want you to write memorize on the bottom of this page, 145. This table is going to be on your quizzes, both of them. It's going to be on your test. This is the most important thing that I need you to understand about these kind of problems, okay? You have three different options. Let's go ahead and start by graphing these lines now, okay? All right, so we're going to start with the first one. You'll notice there's no M and B labeled out. You just need to be able to look at an equation and graph it at this point. So my first equation, problem 1, we are going to begin at 3. Get a fatter marker. We're going to begin at 3, and we're going to go down 5, right 3. Okay, so my graph is going to be right here. My second equation is going to begin at -3, and it's going to rise 1, run 3. That looks like those 5 points. Again, remember, you can slow this down and pause it if you need to catch up. All right, so the question is, what is the solution? What is the answer? Well, these are intersecting lines, which means that my solution is going to be one point, an X and a Y. It's going to be the point where they cross. So what is that point's name? It's 3, -2. That's my answer. 3, -2 is the point that's on both lines. He's my solution. Okay, let's go to problem 2. My first equation is going to begin at a +3. It's going to go up 4, right 1, except that doesn't fit on the graph. So we're going to go backwards. Down 4 and left 1. Take a second to graph that first line. Okay, my second equation is going to begin at -2, but it's going to go down 1 and right 1. That's what a -1 slope looks like. So you should have a whole bunch of points for this one. We're going to connect all the corners for a -1 slope. All right, so for this problem again, we have intersecting lines, which means they share one point, one X and one Y. The point that they share is this. They share that solution, -1, -1. That is our final answer, okay? All right, let's go ahead and hit number 3. First equation on number 3, it's going to begin at -1. And it's going to go down 1, right 2. That's a -1/2. Make sure your graph is going downhill. Oops. All right, so we got our first line drawn. Let's look at the second one. Our second line is going to begin at -4, and it's going to go up 1, right 4. So it's going to hit this dot again, and then this dot. So our line has 3 dots, and it looks like this. Perfect. Remember, you can pause anytime you need more time to draw those graphs, okay? We have intersecting lines, which means we share only one solution. Our point is an x and a y, and it is the point 4, -3. So for these kind of problems, the graph is your, quote, work. The box, or the point, that is your final answer. Make sure you need to show your work and give a final answer, okay? Let's try problem 4. Remember that f of x is the same as writing y equals, so we're going to graph y equals -1. Well, that's a horizontal line going through -1. Second equation is going to begin at +4, and it's going to go down 5, right 2. You should be able to fit 3 points on your graph. Oops, too fat. Switch this guy out, make him a little thinner. There we go. Now it looks normal. All right, so again, one more time, we have intersecting lines. My answer is where they cross. So 2, -1. That's my final answer. All right, so we've done 4 where we have intersecting lines. All of those have one solution. So for 5 and 6, I want to zoom in, make sure that we know these are a little bit different. Okay, so problems 5 and 6. Number 5 is tricky to start with. I'm going to change to a gray highlighter real quick. Problem 5 is tricky because right here, we don't have a y equals. We have this 4, and that 4 is on the wrong side for us. So we're going to move him to the other side. What I do to one side, I must do to the other. I'm going to cancel off that 4, and now I have the equation. Y equals 3x minus 4. Okay? Let's graph the top one first. I'm going to start with -4, rise 3, run 1. I should have 4 dots on my problem. When I go to graph that second equation, I'm going to change colors real quick. Notice that I'm going to hit -4, rise 3, run 4 again. What do you notice about those lines? They're the same. Good. Hopefully you said they're the same. So they are the same is what you see. That's not your answer. Let's look back at our other problem. Okay? When you see the same lines, your answer is infinite solutions. Okay? So just to be clear, when you see the same lines, that's great, but your answer is infinite solutions. Okay? And that's what we're writing on our paper. They share every point in common. Okay? Last one, number 6. All right, number 6, first equation, we are going to start at 2. We're going to go down to right 1 because it's a -2 slope. Go ahead and graph your first line. Pause it if you need more time. And then we're going to graph the second line. We're going to begin at -2 and do the same slope, down to right 1. When we do that, or maybe even before we graphed it, you should notice that if they have the same slope, they're going to be parallel. Now, parallel is what I see. It's not the answer. So let's zoom out again. If I see parallel lines, this is my answer, okay? So if I see parallel lines, my answer is no solution. They don't share any points in common, okay? So I'm going to zoom out. If you need more time to write any of those answers, you can. Otherwise, your homework is going to be page 146, 147, okay? Make sure you complete all the problems. If you have any questions, please come see me.